Consider this example. Given a line AB and a point C outside of it, construct a perpendicular from C to AB. Shall we start the construction? Here we are. Mark any point A, one more distinct point B, join A and B, mark a point C outside of AB. It may be above or it may be below, it may be anywhere, but not in line with AB. Draw an arc with the center C with a convenient radius to intersect AB at D and E. Now, with D and E as centers and taking more than half the length DE as radius, for both the arcs, draw two arcs which intersect at P. Join C and P. Let CP intersect AB at F. Join C and F with a thick line. Measure one of the angles at F. It is a right angle. Therefore, CF is the perpendicular drawn from the external point C to AB. Now, it may so happen that the arc drawn from C to AB may fall outside of AB. I am illustrating it with an example here. First, let us draw AB. Then mark a point C outside of AB as before. Now draw an arc with center C, but the arc doesn't intersect AB at all. So, in this case, we need to produce B in such a way that it intersects the arc at two distinct points. Now the remaining steps are as in the first construction. I am going fast with these. Now that is point P, join C and P, intersecting point F, join C and F with a thick line, and you may want to measure one of the angles at F. It will be and it must be 90 degrees. What is the geometrical theory behind this construction? Let us discuss now. We need the figure. Let us get it. Here it is. We need to prove that CF is perpendicular to AB. That is, angle CFB or angle CFA equals 90 degrees. To do that, we need to do some extra constructions. Join CD, then CE, DP, and finally EP. The justification we are going to give here is very similar to the one we gave in case of perpendicular bisector. First, we prove triangle CDP and triangle CEP are congruent and get the additional information we want to prove triangle CDF and triangle CEF are congruent. Let us start. In triangle DCP and ECP, the big triangles, here they are. This triangle and this triangle. Here CD equals C. Why? Because they are the radii of this arc, radii of the same arc. Then DP equals EP. From D and E as centers, we have drawn two arcs with equal radii to locate point P. So, arcs drawn with equal radii. Of course, CP is the common side. CP equals CP. It is the common side. The three sides of the first triangle are correspondingly equal to the three sides of the second triangle. This is a case of SSS rule of congruency that is applied. By SSS rule for congruency of triangles, we have triangle DCP congruent to triangle ECP. In two congruent triangles, corresponding sides, corresponding angles must be equal. So, we need this angle. Angle DCP equals angle ECP. These angles can also be named as angle DCF and angle ECF. Let us name this as equation 1. Now, consider the above two triangles, this triangle and this triangle. Triangle DCF and triangle ECF. Here, DC equals EC and CF equals CF. For the first, the reason is arcs drawn with equal radii. Second one, it is the common side. Now, we have proved this result. Let us make use of this result here. Angle DCF equals angle ECF. It is from equation 1. Now, look at the figure. This side is equal to this. This is the common side. The angle subtended by these two sides is equal to the angle subtended by these two sides. Therefore, this is a case of SAS rule for congruency of triangles. By SAS rule for congruency of triangles, we have triangle DCF is equal to triangle ECF. Therefore, corresponding angles must be equal. This angle must be equal to this angle. We need this pair of angles. Let us call this equation 2. Now, these two angles, this and this, these two together make a straight angle. Their sum is 180 degrees because AB is a straight line. Let us call this equation 3. Now, we have angle DFC equals angle EFC. We shall plug in angle EFC in place of angle DFC to get this equation. Angle EFC plus angle EFC equals 180 degrees. This is from equation 2 and 3. That is 2 times angle EFC equals 180 degrees. Angle EFC equals 180 degrees divided by 2 equals 90 degrees. This is what we needed to prove. CF is perpendicular to DE. That is, CF is perpendicular to AB. CF is the perpendicular drawn from the external point C to AB. Hence, the justification for our construction. Did you get it? That's it for now. Keep watching my videos. Bye.